Hello coders, this is Caro, and in today's video I'm going to talk about my computer science degree. This video is for you if you studied computer science, you consider studying computer science, you study computer science now and you want to know how your degree might be useful in the future, you study or studied some other tech or engineering degree and you just want to see how those two compare, or you just want to know how many classes I failed and how it didn't prevent me from getting jobs at Canva, Microsoft or Google. So if you fall into any of those categories, consider giving this video a thumbs up. It helps me a lot and it helps the channel to get visibility and some more love from the YouTube algorithm. Let's get to it. So I studied computer science at the University of Warsaw. I started in 2012 and I did my bachelor's, and right after that I did my master's, 5 years altogether. I knew how to code before I went to uni. I was already kind of working and freelancing, selling some websites, writing some of my Android apps on the side. A little bit context about my uni. It's mostly maths and algorithmic centric. It produces a lot of competitive programmers like Kamil Dębowski, or as you might know him from YouTube, Richter. And my uni also has a wide choice of different specialties. So it can be algorithmics, it can be distributed programming, embedded systems, automata, and more of a formal theory around software engineering and computer science, or even AI and machine learning. University in Poland is free, so there was no question for me whether I want to do it or don't want to do it. I knew that this is something that would definitely benefit me and there's no cost on my side. The university I chose, University of Warsaw, is considered, or at least back then was considered, the best university for computer science in Poland. I hope it still is, but who knows, I left. So the system of getting into uni in Poland is a little bit maybe different than what people are usually used to. You actually write an exam or like a set of exams at the end of high school. You can write it in like the basic or the advanced level. To get into my university, specifically for computer science, you were only required to have advanced maths, but the whole score was calculated 80% your score from maths, 10% English and 10% Polish. And I had 88.8 points, so I think that's a Chinese lucky number. Lucky me, I got in. After you graduate and you want to go into master's studies, the process is a little bit different because you need to pass the internal test, but maybe more about that later when we get to the master's degree. So for computer science, each year is 2 semesters. There are 3 years of bachelor's and 2 years of master's. So first year of uni is mostly foundations of computer science, which is algorithmics, a lot of maths, a lot of deep understanding around memory management and pointers and all of those things. All classes are obligatory and there are no optional choices. So the way we're gonna do it is I will give you an overview of all of the classes, and after each overview I will also give it a score of how fun they were and how useful they were in the future. Each of them will be on a scale from 0 to 5. So first semester, winter. We start with foundations of mathematics, which is mostly set theory and familiarizing ourselves with the formal mathematical language and base ways of constructing mathematical proofs. In terms of fun, I would give it 0, but in terms of usefulness, I would give it 5 because it built the foundation for us to learn all of the other parts of maths that are actually more interesting and more useful. Next one was again maths, geometry with linear algebra. We talked about complex numbers, matrices and matrix operations, and linear spaces and equations. In terms of fun, I think what was missing were real life examples and usages, like applied knowledge around that. But in terms of how useful it is, I would totally give it 5 because I use it all the time now that I'm working as a video editing software engineer. Next, another maths. Mathematical analysis for computer science 1. I'm gonna literally read it from my notes because So what we had there was axiomatics of real numbers, sequences, series of numbers, limit and continuity of functions of one variable. So in terms of fun, it was 0. It was horribly boring. In terms of being useful, I would give it maybe 3, as I'm using some of that now for the video editing processing. I can think about other domains of software engineering where this would be really useful. It's just not for me. And then the last one in this semester, Intro to Programming. We had both theory and practice, and the practice was using Pascal, which looks kind of like C, but no one uses it. We talked about algorithms and complexity. It was all imperative approach to programming. So we talked about like the representation of numbers, variables, loops, if statements, plus horse logic and proving programs' correctness. The next semester, happening in the summer, fortunately had more programming than maths. Also, a lot of people already left as they realized that programming is not for them. So I think there was probably like around 300 people starting with us, and at this point there was just 100 of us. So we have 5 different courses this semester. First is individual programming project, which was not fun and not useful at all because it was using Pascal and Delphi, which no one uses. It was kind of a continuation of the introduction to programming, but based on building more complex and whole programs, as well as including some graphical user interface. I wouldn't say it was completely useless, because you could transfer this knowledge into another language. I just don't understand why they forced us to use a language that no one uses. Next is object-oriented programming, and finally a commonly used language, which is Java. It wasn't too much fun, but it was quite useful. I will give you a quick overview of all the things we were learning during that one semester course. Object-oriented domain modeling, UML notation, encapsulation, creation, initialization and destruction of objects, inheritance and polymorphism, interfaces, exceptions, generics, collections, streams, serialization, design patterns, and GUI. So we can see there was actually a lot happening there and a lot of concepts were presented for us. Next one was computer and network architecture. We started with logical gates and operations on bytes, byte order, microprocessors, memory, like the actual physical interfaces, a lot of the theory behind how the computer is actually built and how all the elements work together. At the end of the course, we moved more towards network architecture and mentioned a few topics around that. Next was mathematical analysis for computer science 2. Again, no fun, 3 out of 5 usefulness. In this course we had one variable integral calculus, many variables functions, differential and integral calculus. I have to read this because I was literally learning this in Polish and then I have never used it after that. So I don't know all of those English names for this. So I probably don't even remember the Polish ones. Next one is discrete maths, and that's the first ever course that I failed. Why did I fail it? Because I was playing too much Guild Wars 2 and I didn't have time to study, of course. So after I uninstalled Guild Wars and I actually took my studies more seriously, that became one of my favorite courses. It encapsulated combinatorics, graph theory, and number theory. During the second year, we had more of the practical classes, a little bit less of theory, still a lot of maths, but everything was much more computer related. Third semester started with algorithmics and data structures. In terms of fun, I would give it around 3, just because the solving problems and learning algorithmics is fun, but it was also really stressful and really difficult and really packed a lot of different topics into this one semester course. In terms of usefulness, I would probably give it 4 or 5 because it pretty much prepared you for the interviews at Google, Microsoft, or whatever other big tech. So the course overview is basic principles of analysis of algorithms, methods for designing efficient algorithms, sorting, selection, priority queues, searching in dictionaries, find union problem and its applications, graph algorithms, text pattern matching, data structures for text processing, databases. During that course, we learned about systems and data modeling, relational query languages, and query optimizations. In terms of fun, I would give it around 2, just because I was able to update my app as a part of the course. So instead of writing a Twitter bot, I just updated my Android app to use SQLite. In terms of usefulness, I would give it 5 because I think everyone should know that it's something that will allow you, even if you are not a database engineer or data engineer, it will allow you to be more mindful about querying, organizing queries, and that's just something you should know. Next one, we have operating systems. So that's pretty much how operating systems work under the hood. Things like hardware support, process execution, interruptions, scheduling, all of that. And as a part of the practical project, we were actually modifying a scheduler in the Minix system, which is like a really simplified Linux written in C. Next is probability theory and statistics. Forget everything you know from high school and just get ready to get your brain twisted. The practical tutorials were using R, but there wasn't much of it, and that's just the second course I failed, mostly because there was just so much theory and it was not interesting to me at all, so I just didn't manage to pay any attention. Motivation very low. Next one is first of the series of 3 languages and tools of programming. This one was all in C++, and that was mostly just practical, where we had to write more and more complex projects individually or in pairs. That was also the first time that functional programming was introduced to me. It was very fun and very useful. 4th semester starts with languages and tools for programming 2. And to be honest, I really just don't remember what was happening then. It was kind of like a lot of PhD guests would just come and like run the classes, and they wouldn't even really like seem to want to run those classes. And I just don't really remember anything useful that came out of this. So I'm just gonna give it 0 and 0. Next on, we have web applications. So HTML, CSS, JavaScript, Ajax, and just some basic security. Not very fun, but I guess very useful if you are planning to go more into the front-end direction. If you're thinking about backend, you still should know that. Next on is social and professional issues of computer science. 0 fun, 0 usefulness. That was just like talking about the ethical problems we can face, and there was a little bit about like the business, starting a business, and like potential like IP. The delivery was really bad. So yeah. Languages, automata, and computations. This is mainly automata, grammar, Turing machines, Chomsky hierarchy, a lot of very high-level theoretical things, and as it was a lot of fun to solve those problems, it's not really that useful. I don't even really remember anything anymore. Computer networks. So that's like physical and the digital layers of networks, protocols, and security. Like the whole course was pretty much how does the internet work under the hood on the physical and the digital layer. Nice. I would give it 3 in fun and 3 in usefulness, just because it's good to know and it was interesting to learn. And the last one for the semester was just called software engineering. And that was quite an interesting one because it was all about designing and implementing systems. I would give it 4 out of 5 in the fun section, this 1 point just because you were not allowed too much creativity, and 5 out of 5 in usefulness, just because this is something you will always do at work. And the last year of my bachelor's degree, 5th semester, starting with languages and tools for programming 3, and same as before, useless. Next up, text algorithms. That was actually something I could choose from. Probably I had a choice between like 3 or 4 different courses, and I chose text algorithms, which tell you how to search text in the most optimal way, as well as teaches you kind of compressing techniques for text. In both fun and usefulness, I would give it 3, just because even though it's really fun to learn and it's really fun to know, you wouldn't really use it unless you are in that specific niche. Security of computer systems. That was just cryptography, and that was great. Much fun and quite useful now that Bitcoin. Numerical methods. That's just all about efficient ways to implement maths-based problems, and I'm going to give it 0 because I don't remember anything. Program semantics and verification. This one was a pretty cool one, as we started with a theory but then ended up implementing our own interpreter. So as you might know, there are languages that compile and there are languages that get interpreted. So here we were writing an interpreter for a C-like language, and we're writing it in Java. I would give it 5 out of 5 for fun, and probably something around 2 out of 5 for usefulness, because you're probably not gonna do that again unless you're developing your own language. And now coming to the 6th and the last semester of Bachelor's of Computer Science, and that was the best semester of the whole program. I think mostly because we had a broad range of courses we could choose from, and there was only one obligatory one, and that was programming languages and paradigms. And it was actually great because we were introduced to object-oriented programming again, but this time based on Smalltalk, which is like one of the first, or even maybe the first, object-oriented language. We were also introduced to functional programming with Haskell and programming in logic with Prolog. I loved it. I think this one course made me a much better programmer, just because it allowed me to think different about approaching problems by knowing different paradigms of programming. So 5 and 5. Then my course of choice, microcontroller programming. And this is how I met my later master's thesis supervisor. It was so much fun writing those really low-level programs and actually connecting all the hardware into something that you want to make and you can physically see it working. So for my project, I made some kind of like a Game Boy with this dungeon game that was controlled with a joystick as well as gyroscope and accelerometer. It was fun. It was a lot of fun. I would say 10 out of 5 fun, probably 2-3 out of 5 usefulness. But also considering that I wrote my master thesis in the same domain, maybe 5. Another course I chose myself was machine learning, and I'm happy with that choice. I learned about supervised versus unsupervised learning, reinforcement learning, learning functions, and concept approximation. It was really fun. The practical projects were really cool. We had a lot of freedom in the way that we choose the algorithms and languages we want to use for it. And I think everyone should know that, just to draw the perception of machine learning being some magical thing. So then alongside that, I also took artificial intelligence and expert systems. It was all mostly artificial intelligence algorithms in like the space of game strategies. So we were just learning like different methods and algorithms to approximate the winning strategy. During that last year, we were also writing a thesis. It was a project developed in the group of 4 people. It was usually ordered by some company from outside of uni. Sometimes they would pay you, sometimes they wouldn't. Our project was called Real-Time Data Visualization Platform, as the company who ordered it was collecting a lot of data from windmills and another renewable sources of energy, and then they wanted to show it in form of graphs. After we wrote the program, we wrote a thesis around it, and then we had to present it in front of the whole year and all the professors. The second part of kind of getting the degree was passing a test, and that was the difficult part. The test would encompass all of the knowledge we gained during the whole 3 years. Most of the questions were of multiple choice and 2 of them were open. Luckily, or because I'm really smart and I studied a lot, I passed the test with one of the best scores that year. So I hope this gave you some idea about what to expect from university and if it's the right thing for you. Also keep in mind that every university is different and it's important to check the offering before enrolling. Another aspect you might want to consider is whether you have to pay for it and how much. I was lucky enough not to have to pay anything, as education in Poland is free. So after watching this video, one thing I would like you to remember is that being successful at uni and having good grades is not essential to landing a good job. Uni is for you to get as much knowledge as you want and explore all the different paths that are now available to you. And don't worry about grades as much, because as you can see, I failed like 2 different courses and then I fixed that up next year and everything was fine and I'm having good life and good job. So don't worry about grades. Go to uni if you just want to explore more of the computer science offerings and you just want to find your path. So if you want to hear more about how to best spend the time at uni or how to prepare to land a job at big tech or a startup, give this video a thumbs up, subscribe to not miss any of the other videos. Clicking the notification bell can help here too. Thanks guys!